mass, whatever the units of mass are in this problem, grams.
Okay. Yeah, that's about right.
Any questions on that before I move on
Yeah,
to
no, that looks
next
about
one?
right. It's just
Okay.
kind of, just jogging up the old memory
Yeah,
thing.
these are pretty much the same in terms of like, you have to give, this one is the same as pre-1 where there's kind of a sentence that they always are looking for.
Right, like
And
to show that you understand it.
yeah, but it's kind of like a regurgitation parrot type thing where you maybe you don't understand, but you know how to actually formulate it here.
Right.
So the R squared value tells you the percentage of Y explained by X.
Percentage of Y explained by X.
Okay, so again, it's a put these numbers in. So we would convert that to 81.9% of, and I'm gonna add a word here, variation in, and then instead of Y, we'll say mass, is explained by length. So I'll add that word in here.
The coefficient. Okay, so you would just convert it into a percentage.
Yes.
And then just regurgitate of variation in
Yes.
Y is explained by X.
Yeah.
Okay.
Then this number is actually really, really important when you're doing modeling, but they're not asking you to understand that. They're just asking you to provide a sentence here. But this number is super important. Like if you were to come to me, I would say, well, can we do better than that? Because that actually means there's almost 20% of unexplained variation. And that could be really high depending on what you're doing.
Right. Interesting. Okay.
Okay, let's look at letter D. From plot 2, consider the residuals of the 11 bullfrogs. Okay. So let me grab the graph and maybe we can talk about if it's not clear what an actual residual is. Residual is Y minus Y hat. Okay,
right.
And the Y hat comes from the predicted or from the equation. So for example here, let me pick this point A. So the residual at A would be, let's see, Y is approximately 510. And the Y hat, the predicted value, which is along the line, is probably around, I don't know, say 470.
Yeah.
Okay, so that is now there's 11 residuals, meaning one for each of these. Okay, now we can get to what the question asked for, but is it clear what a residual is?
Yeah. No, I remember. It's just like the point in between the residual line and the actual point.
Yes. Okay, some are positive, some are negative. Okay, now the question here asks for the length and mass of the bullfrog with the largest absolute value residual. In other words, they're saying which point is the furthest from the line. And I think we're going to go with this one right here.
That one?
Yeah.
That's about the furthest from.
It's very deceptive.
Ruler, but
yeah. A little bit tough to see. I mean, you might be drawn to some up here. Now they're actually asking for you to say like B is, and I don't know if you have the data, but you'd want to say that the length or the X is 162 maybe. Mass is 355 maybe.
Yeah, no, they didn't give too much of the data. They just gave you the graph pretty much.
Okay, so you're just sort of estimating that.
Yeah.
There, any questions on that or any?
No. So just Great. That was about definitely a little bit different than what the teacher taught, but it's good to get multiple perspectives on how to answer these questions.
Yeah, I mean, what if there are differences and it's contradictory, please ask, because I'm I'm not here to make your life more difficult. I'm here
No,
to.
no, no,
you- Yeah.
it connects, but yeah, no, it's good for now.
Does the least squares regression line overestimate or underestimate the mass of the bullfrog identified in part D? It's kind of a complicated way of asking, is point B above or below the line of best fit? So if we can just make sort of a broad statement, if the point is below the line, okay, it's the line
It's an underestimate, right? Or is it overestimate?
the line overestimates. Yeah. So that's,
Oh,
and if it's above the line, that means that the line underestimates it.
I see. Okay, I do remember this part where it was just like it was kind of a flip flop of it.
You got to be careful whether you're talking about the point or the actual point or the prediction point.
Right.
Um,
Okay.
because there's other ways to like look at it, but I think it's simpler to just say, is the actual date, because the prediction line, the points are always on that line. So your data value, is it above or below, is the only sort of, logical way to look at that. Keep it simple. Any questions on that?
No, it looks good. So
All
it's
right.
so the line is, so it would be an overestimate, right?
The line overestimates it at B.
Yeah.
Yeah.
Okay, it does, because that's the actual point. Okay, all right,
Yes.
perfect. All right, let's get question 2, and then there's this question 3.
All right. Just give me a moment here to get this snipped
Oh,
in here.
no worry, you're all good.
Here we go. All right, a machine at a manufacturing company is programmed to fill shampoo bottles such that the amount of shampoo in each bottle is normally distributed with a mean 0.6 and standard deviation 0.04. Let the random variable A represent the amount of shampoo in liters that is inserted into a bottle by filling the machine. A bottle is considered to be underfilled if it is less than 0.50 liters of shampoo. Determine the probability that a randomly selected bottle of shampoo will be underfilled. Show your work. All right. Can you tell me mu, sigma, x bar in this problem?
So mu would be 0.60 liters.
Okay, good.
And the standard deviation would be 0.04. And then X bar would be 0.50 liters, right?
Yeah.
Okay.
All right. So we're trying to find the probability. Now I normally use X, but it's in this case, it wants A less than 0.5.
A less than 0. Oh, 0.5. Okay. Yeah,
Because that's where it's underfilled.
Right. That's when it's determined to be underfilled.
Yes. And by the way, like companies really do this. There are quality control companies out there that they pull something off the line and they measure it to make sure, like they look at the data to make sure things are okay.
Right. So
Okay.
statistics we're going to jobs.
Yes, there's actually real jobs doing this. Okay.
Crazy. No wonder it's so important.
Yeah. So you got to calculate a z-score here. Do you remember the formula for z-score?
I believe so. Hold on. I don't know if I can remember it by heart. But z-score was. I don't know if I can remember it.
Okay, so we got x bar minus mu
Over
over
the
sigma divided by the square root of n. This is
Yeah.
the general form. It says because it's a bottle, that means that n is 1.
Right. Okay.
So for you, it's 0.5 minus 0.6 over 0.04. If you could calculate that for us, please, I'd appreciate that.
Let's see.
And you're welcome to use a calculator. That Desmos Scientific.
Yeah, I think I'm gonna have to. My little fancy calculator's been acting funky on me and hasn't been charging, so I don't know what's going on with it. Let's see, let's try calculator. 4. I got negative 2.5.
Yes, so Z is negative 2.5. I think it's good. I mean, that does take, hang on, let me see here, actually. No, we got to find the probability. All right.
Right.
So I think it's good to draw a normal distribution each time. The zero is right in the middle, minus 2.5 is somewhere there. And
Yeah.
what you have to decide, and it's based on the inequality here, is are we shading left or right of this value?
We'd be shading left, no?
Yes, left.
Yeah.
Okay. And then you can use a table, you can use your
Yeah,
calculator.
I got the table A right here.
And so give me that
0,
value.
0.0062.
Say that again.
0.0062, I believe.
Okay, that sounds reasonable. All right. So that's your area. Okay. Now let's see what the next part has for us in store here. Okay, so that actually is it for part A.
So that would be the probability is 0.0062.
Yes, yes.
Okay. Equal 0.0062. Okay, there we go. I need a refresher on how to do that one. It's been a minute. Okay, perfect. All right, and then going down, after the bottles are filled, they are placed in boxes of 10 bottles per box. After the bottles are placed in the boxes, several boxes are placed in a crate for shipping to a beauty supply warehouse. Manufacturing companies contract with the beauty supply warehouse states that one box will be randomly selected from a 2 or more bottles in the selected box are underfilled. The entire crate will be ejected and sent back to the manufacturing company. Beauty supply warehouse managers. The warehouse will be just as soon as the oxygen bottles are independent of each other. Find the random variable of interest for the warehouse manager and state how the random variable is distributed.
Okay, so let me make some suggestions here. This is like going back a long ways, but maybe drawing a picture here. There are 10 bottles per box. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's 10 bottles.
Mhm.
So your world is limited to 10.
Right.
Okay. And from part A, there's always like a reason you did part A. Part A says that the probability that any one of these will be underfilled is 0.0. What did you tell me? 0062. Okay. What are we interested in? It starts right here.
If 2 or more bottles in the selected box are underfilled.
Yes. So we're interested now in the probability that X is greater than or equal to 2.
Okay.
But X is now different. X is like,
right.
X is referring to this
So
in here.
10. So we would have to look for the Z-score once again, plugging
No,
10 instead?
you're jumping too far ahead.
Okay.
Too far ahead. We care whether 2 or more of these are underfilled. Okay. So it could be that 2 are underfilled, or it could be that 3 are underfilled, or 4 or 5 or 6 or 7 or 8 or 9 or 10. But there's 2 choices. They either yes, underfilled, no, not underfilled. This is going back in the Wayback Time Machine. Do you remember a distribution where there's only 2 outcomes?
Right. Yeah. The yes or no or.
Yeah. Do you remember the name of that one?
Oh, I can't say I do off the top of my head. No.
All right. So this is binomial.
Binomial. That's right.
Binomial because there's 2 outcomes. It's also because there's a fixed number of trials, 10 in this case. So they're looking for the words like X is a binomial distribution where X represents the number of unfilled bottles. Or I'm sorry, underfilled bottles.
Right. And that's the variable of interest.
Yes. So notice there's no calculation for I. It just is to define.
Right.
So the grader's looking for binomial distribution and number of unfilled bottles. Like they're grading a lot of these, and teachers get really excited about being on the grading team, but they're literally looking at like thousands of these where they just check And
Right,
that's how you get the
right.
points.
Huh, interesting, okay.
Okay. All right. Part 2.
Ah, okay, and this is where we get into
This
it.
is the actual numbers. So just in terms of like how you do well in the AP, it's not overdoing it when they just ask you to define something. Like
Yeah, okay, so it's
you
best to stay short and simple.
yes. And then if you have time, then do 2. But you can get a lot of the points by doing, A
Just
and part B high.
right, okay.
So this is where you've got to remember a little bit about binomial distributions. I kind of hinted at that. It ranges from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. You don't want to do 2, 3, 4, 5, 6, 7, 8, 9, 10. You want to instead do the 1 minus the probability that X is less than 2. And that's just 0 and 1.
Right,
So it's 1 minus the probability that X equals 0 plus the probability that X equals 1. And that's what they mean by show work. Now, I've not done a binomial distribution by hand in a long time, but you can do this.
okay,
It's the NCR, oops, that's lowercase n, NCR, and then you have your P to the N, Q to the N minus R, no, 1 minus, something like that. Okay,
wow.
you might want to look that up. I would go right to a calculator.
Yeah,
I'm not sure.
that's mainly what she did too.
Yeah, I'm not sure that this is like, this might be showing your work up here. Because your calculator will do that. It's the binom, very important, CDF,
Right,
CDF, because you're doing more than one. And I don't remember what, I'm sure you've got to set like X, P, and N in there. Your
yeah,
X will be
yeah, no,
1.
that's all about right.
P is the 0.0062. Is that what we said? Yeah, 62. And N is 10 like that.
Yeah, it's about right.
And then you put that in your calculator. I think they also really emphasize that you show what you're putting in the calculator. You don't actually have to calculate it in the calculator.
Right, it's just, yeah, just determining it. Just showing the work.
Yes.
Okay, all right, I'm sure I can get a calculator tomorrow and try to do that, but
Do you need the answer right now? Because I can do that for you real quick if you need it.
I just don't have a calculator on me that has the binom on.
Okay, well, I'll give it to you.
Thank you. Sorry about that. It's just these new ones can be really finicky sometimes. It's annoying.
Yeah, no problem. All right, so binom, you can also do this in Excel if you ever need that. So 1 trials is 10.0062, and then we want true. And then we're doing 1 minus that. Okay, so the part that I just gave you, sorry, let me undo that part. Sorry, I'm in another screen doing that. So the answer to this is 0.9983, but you want to do 1 minus it. So it ends up being 0.0017 is your final answer.
Okay. Right, because you're just doing the smaller part and then minusing
Yes,
it from
that's right.
the 3 to
That's
10.
right.
Okay.
That's right. All right. Well, that it goes fast. That is the end of our abbreviated session.